In this lesson, we'll be reviewing functions, their terminology, and some examples. And in the hope that when we finish, you'll understand functions. So we call this understanding functions. And here are some phrases that are typical. B is a function of A. B equals f of A. Values for B depend on values for A. And A determines a unique value for B. Now there are three types of function notation that we can use. First, a data table. So let's look at one where we have the months of January, February, and March. And we'll look at the number of tires sold in each of those months. Say in January there were 50 sold, in February 45, and in March there were 50 sold. And we're going to look at this from two directions. First, is month a function of sales? Or does the month depend on the number of tires sold? I can also write this. Let's say that month is represented by the letter M and number of tires sold represented by the letter S. So I can say, is M equal to F of S? And that's our question. So S is the input. It's the one we choose to give us an output of M. I choose 50. I get the output of January. I choose 45. I get the output of February. I choose 50. I get the output of March. Well, now, there's where there's a problem. I have an input, but my input did not determine a unique output. If I choose 50, I can get either January or March, so that I cannot say f of 50 equals some particular number or a particular month. So I do not have a unique output. For S equal to 50. So that means M is not a function of S. Now we're going to look at this from the other direction. Part B, we'll decide, is sales a function of month? Or in the shortcut notation for a function, is S equal to F of M? So this time M is our input, S is the output. I put in a month, I put in January, I get out 50 for the number of tires sold. I put in February, I get out 45. I put in March, I get out 50. So I have January's input, 50 for the output, March input, 50 for the output, but it doesn't matter about there being two 50s on here, because the question says one input yields exactly one output. And that is the case. If I take the month of January, put it into the function, the only output I get is 50 tires. If I put in March, I get out 50 tires, but one input yields exactly one output, so that my input does determine a unique value for the output. So yes, sales is a function of the month. Now we're going to look at the second representation. After data table, we also have graphs. So the first graph that we're going to look at we'll put our traditional X and Y, X on the horizontal axis. Because X is on the horizontal axis, X is the input. That's always the case for the horizontal axis. X is the input. We can call it independent because that's the one we choose. The Y value will be our output. And we'll see that Y is dependent. So we want to find out, if I choose X, do I get a single Y? So let's choose this value for X right here. That's the X I'm putting in. I get a Y out there, but for the same X, I get a Y down here. So what I have are two outputs for one input. So that means that Y is not a function of X. If you put one value in, you can only get one unique value out, and here I got two, so Y is not a function of X. Let's look at a different graph. Let's call this value T on the horizontal axis, and we'll call that Z. This is our input. You'll notice that it will be the letter inside the parentheses, and Z is the output. So I put in a value for T. I get out only one value for Z that's on the curve. Over here I put in a value for T. I get out a single value for Z. So I can say, yes, Z is equal to a function of T, my input inside the parenthesis. No matter where T is, whichever one I choose, I get a single output. So input gives exactly one output. So Z is a function of T. Yes? Now we'll look at the third type of representation for a function, and that is a formula. The formula that we're going to look at is Q squared minus 300 equals P to the third power. And we ask the question, first A, is Q a function of P? So if that is the case, we would try to find, is Q equal to F of P? So we would like Q on one side of the equation equal to everything else on the other side. So we want to solve for Q. Q squared equals P to the third plus 300. And then to get Q by itself to the first power, I'll take the square root of both sides. And when I take a square root, I have to account for the positive square root and the negative square root. So whatever value I plug in for P, I'll get a plus and a minus of whatever number remains under the radical. So Q is not a function of P. Because when I plug in one number for P, I get two outputs. Now, there is something that you have to watch out for with square roots. You cannot take the square root of a negative. So if you put a number in for P that's a negative number and is too big, when you take the square root, you won't get a value at all. But that doesn't affect whether or not Q is a function of P. That has to do with domain and numbers you can plug in. So that all we can say here is Q gives a plus and a minus, and that means Q is not a function of P. Let's turn this around now and look at the same function.
Okay, whatever you want.
So now let's look at this from the other direction and try to determine, is P a function of Q? So this time, if I'm question mark, this time I want to know, is P equal to F of Q? So I need to solve for P on one side of the equation. And this time I'm going to flip it and write it this way first. P to the third equals Q squared minus 300. So to solve for P, I just need to take the cube root of that side. And this time let's look at some values. If I plug in a number for Q, I take the cube root of whatever's left and I have one answer. For instance, if Q is equal to 10, P is equal to the cube root of 10 squared, which is 100, minus 300. So that gives me the cube root of negative 200. And because it is a cube root, it's an odd root, that's the same as the negative of the cube root of 200. So I get one single answer. Let's look at Q equal to 20. Then P is equal to the cube root of 20 squared, which is 400, minus 300, which is the cube root of positive 100, which is a single positive number. So for all the cases going in this direction, P is a function of Q because one input yields exactly one output. So that P depends on Q, Q is independent, P is the dependent variable. All the values for Q make up the domain of the function, and P values are the range. So P range, Q domain.